Okay, so having kind of finished our work with computation, we're going to move into looking at some of the algebra concepts that we're going to talk about this year. And so to get ready for that, there's a little bit of vocabulary that you need to kind of know and remember from sixth grade that's going to help you be successful this year. So we're going to start with the page that's called Algebra Vocabulary in your math notebook. And we'll go ahead and fill in the information that's here. So I'm going to right click on it, save to keep, click the box with the arrow to open up a new window. Click again so you get the little pen. And here we go. So when I'm doing this one here, the first vocabulary word is equation. That's not actually where we're going to start with what we do here, but that will be where one word that you want to know. So in a math sentence like this one, you have 3x plus 1 equals 7. That would be an example of an equation. So to be an equation, if you look at that word, it starts with EQU, right? Just like equals does. So it must have an equal sign in order to be an equation. And the key here, whenever you see equals, is that the two sides are the same. Oops. The same. Let me erase that and do that better. S-A-M-E. So they mean the same thing. Even though 3x plus 1 and 7 don't look the same, obviously, they mean the same amount. And that's going to be something that's important as we go forward. Another thing to remember is what a variable is. A variable is a letter that represents a number that we do not know yet. So it's usually what we're going to try to find in a lot of these problems. This year in 7th grade, we're going to do problems that just have one variable in them for the most part once we start with equations. But you'll do some that have two a lot more next year in math. Next word, coefficient. It is a number that is being multiplied by the variable. And coefficients can be positive or negative. Every variable, like it says there, has a coefficient. Sometimes we can see it and sometimes we can't, but I'm always looking for what's being multiplied from them there. So coefficients of the variables below. The first one, hopefully pretty easy. Remember multiplication, one way to write it is to have two things just sitting next to each other. So if you have 3 times a, the coefficient, what's being multiplied by a, which is the variable, would be 3. In the next problem, there's just an x. So it looks like there's nothing that's multiplying, but really, because there's one x that's there, that's the secret number that's in front. We just don't have to write it because 1 times anything is itself. And so therefore, we write, as little as possible so we don't get confused in our problems. So this would be 1. Like we said before, up here, they could be positive or negative. So what's times m? It would be a -4. In the next one, we said it's something that's multiplied by. So really 2w over the 3 is the same thing as 2/3 w. So what's being multiplied? 2/3. So it could be a fraction, that's okay. When you see a negative m, or sometimes we read that as the opposite of m, that's really similar to what we just did with the x, right? So if you see the negative, it's really a -1 that's there. And last but not least, the x over 5, same idea. I can kind of separate the two things here, right? So I have the x, I have 5, and how many x's were there? It was 1. So 1/5 is my coefficient. So we'll practice a little bit more with that, but that's going to be your basic idea. Next vocabulary word we have is constant. So it's any real number that's in the equation that has no variable attached. So if you should just see the number 5, for example, that would be a constant. Another word is term. So with a term, it's going to be kind of each, let's say, we'll say like set or group of coefficients and variables is going to be your terms. And we see them separated by the plus and minus signs or equal signs in the problem. So when I look at the terms, if I do this example that's here, my first term would be the 2k. So it's kind of the set or group of coefficients and variables, if there is one. If it's just a constant, just a constant. My next term would be 15. My next term, and I'm always going to keep what goes to the left of it. So I'd have minus m, and I'd have minus 3, I'd have n, and after the equals, I have a negative 7p. All of those individual things are terms, and we'll talk more about those tomorrow. Variables are the letters in the problem. So this one has a couple. It's got k, it's got m, it's got n, and p. Coefficients are numbers that multiply by the variables, right? So there's a 2 that's times the k. There's a negative 1 that's times the m because it's minus m, like we did up top there. There's a 1 in front of the n, and then there's a negative 7 in front of the p. And then constants are numbers that don't have any variables. So the 15 doesn't have a variable with it, and the 3 doesn't have a variable with it. And that's kind of the idea there. So this next one that's right here that starts with the negative 8, see if you can answer these questions. So go ahead and try to fill it in yourself, pause the video, and then we'll check together. Okay, welcome back. Let's see how we did. So first term here that I have is that negative 8. Then I have the minus 4c. Then I have 7 minus c minus 12c and minus 2. And then m is over there at the end. Sorry, I kind of ran out of space there. Variables, so the letters in the problem. There's c, then there's c appears a couple times, and there's m. Coefficient, so what multiplies by the variables? I have the minus 4 by the first c, minus 1 by the next c, minus 12 by the third c, and then there's a 1 in front of m. And then constants, they're numbers without variables, so that's negative 8, the positive 7, the negative 2. Last word that's on this page here is expression, and this is where we're going to start with our algebra work. It's just a group of terms. So the two ones we just looked at were equations because they had equals in them. But if we didn't have the equals, then we would have expressions. So does not contain and equals. That's an expression. So as an example, we could separate the terms, then label coefficients, constants, variables. So it says how many terms do we have? There's 1, the 8y, then there's minus 7, and then there's 2y. So we'll say 3 terms, and we could list them. So we have 8y, right? Minus 7, and 2y. Our variable in this problem is just y. It's the only letter that's there. Coefficients would be 8 and 2 because those are with the y's. And then your constant would be -7. So again, same kind of idea. Try letter B yourself and see how it goes. Okay, so let's check. You could pause if you're still not done. How many terms are there? Well, there's m, 4, 2, -7m, and 6. So there are 5 things there. And so like we said, we had m, 4, 2, -7m, and 6. And then the variables would be just m. It's the only letter that's there. Constants would be the 1 and the -7 because they're with the m. And then 4, 2, and 6 would be your constants. So once you got that, you can, go back. We'll go back to our math notebook. I can delete this out, pull this one in. And then we can make it a little bigger so that it fills up the page. Then we're going to do one more page before we finish here. So the next one is like terms. And so for this one, we need to kind of fill in the idea of like terms so that we can use that to help us with what we're going to do tomorrow. So a like term is something that has the same variable and the same power, which is an exponent, right? And if they are, like terms can be combined, which is what we're going to talk about tomorrow. So an example of like terms would be something like 3x and 9x. Excuse me, both have x's to the first power. You could also have something like -2xy and 5xy. Again, still to the same power, doesn't matter what coefficient you have. I could also have things to the second power, third power, etc. So non-examples of things would be something like, let's say 3x and 5y, because they don't have the same variable. Or something like, let's say 3x and 6x squared. To make the little square go above, I can highlight it, go format, text, superscript. So those two are not like terms because they don't have the same variable. So I'm going to take this list here. Again, right click, save to keep. Oops. We will open it in the new tab. Click on it there. And we're going to try this out. So remember, same variable, same power. So 4x and 3x, are they like or are they not? And I could say that they are like. And how do I know? Because they have the same variable, right? They both have x. 5xy and -8xy, are they like or not? I would say they are like because they have the same variable part. It's two of them, right? xy, but still both have xy. 3m squared and -6m squared, are they like or not? I would say like because they have the same variable part. They're both m squared. 4 and -2, are they like or not like? So really that they don't have the same variable means kind of that they do, right? So it's a like term. We could also think of it as a variable to the 0 power, but that's something you'll talk about more next year in math. And the reason they're like is they're both constants. So constants, all constants are like terms. 5 and 2, are they like or not? They would be not because they don't have the same variable, right? One of them has an x and one of them doesn't. 4x and 3y would be not, because they don't have the same variable. One is x and one is y. And 4x and 3x squared would be not, because the variable doesn't have the same power. And that's the idea with like terms there. So we'll go back, put this part into our math notebook. When it appears. And then remember, this is a longer video, so it's probably going to be easier for you to go back to this as you finish, so that you can go ahead and check your answers before you submit your Edpuzzle questions.